All right, so we already talked about how to solve systems of equations. We know that systems are two or more equations or inequalities, and we know that when we graph them, the place where the two equations equal each other is going to be where they cross. So if we solved systems graphically, which is what we were doing before, then we graph them, see where they cross, we're done. Today we're going to solve systems algebraically, which means we're going to be taking the systems and we're going to see where they equal each other, but we're going to do it all by hand. So there are two methods that are typically used. One is elimination, the other is substitution. So we're going to go ahead and start with elimination. So the goal in elimination is to take the two rows and get one of the letters to completely cancel out. And sometimes you have one clear option that's better, and sometimes you have two options that seem like they would work equally well. So here I can get the x's to cancel if I can multiply this entire line by 5, because then 5x and negative 5x would cancel. Or here I could multiply this entire row by negative 2, because then negative 6x and positive 6x would cancel. It doesn't matter which option I go with, both of them are going to accomplish the same purpose at the end. So I'm going to go ahead and take the second equation and multiply it by 5. So I'll go ahead and I'm dropping down the first equation. I'm not making any adjustments to it. I'm leaving it exactly as it was. And then for the second equation, I just have to make sure to distribute that 5 throughout the whole problem. So 5x plus 30y equals, and then negative 28 times 5 is difficult to do in your head, so I went ahead and typed it in my calculator. And then all I do is I just add straight down. So that adds up to 0, which is what I wanted. And then I've got 33y equals negative 165. And now to solve for y, I can divide by 33. And I get y equals negative 5. So if you guys recall from when we solved these graphically, we always have to have an x-coordinate and a y-coordinate, and we write them like a point. So now I have the y-coordinate, I need to find the x-coordinate so I can write my final answer. So you have two options. You can take the y value and plug it in for this y right here and solve the first equation, or you can take this y value and plug it in for the second y right there and solve the second equation. And I'm going to go ahead and do the second equation because it had that x all by itself, and that's kind of nice. All right, so I have x plus 6 times the y value that I got equals negative 28. And then I can go ahead and add 30 over to the other side. So I get x equals negative 28 plus 30 is 2. So I have 2, negative 5, and that's my solution. So if we were doing this problem like yesterday, then what we would have done is we would have taken the two solutions, or the two equations, we would have graphed them, and then this is the graph we would have seen, and we would have noticed that they crossed at the point 2, negative 5. So it's exactly what we did yesterday, it's just a different method for solving, but we're still finding the same information. All right, let's go ahead and try this next one. So again, we have two options. We can multiply this maybe by a negative 5 to get it so the x's will cancel out. Or we could multiply the y's by something to get the y's to cancel out. It doesn't really matter. So what I'm going to do is I'm just going to try to get rid of the x's again. So negative 2, I need to multiply that by negative 5 to get it to become a positive 10 so the x's will cancel. So if I distribute, that gives me 10x plus 5y, negative 5 times 0 is 0. So if I add those straight down, those add up to 0, those add up to 0, that adds up to 1. So what happened here is I don't have a variable to solve for. My variable is completely gone. And I have an equation that's not true. 0 does not equal 1. That is false. So any anytime that happens where your variable completely disappears and the equation is false, the answer you get there is no solution. And I want to show you a picture of what that looks like because we did these problems yesterday, but they looked different when we found them. So here, if you look at these two equations, there's our two equations. When I graph them, they're parallel lines. So there's no solution because they never cross. So this was easy to see when we did it graphically. Now, when we do it by hand, this is the sort of thing that's going to happen if we have a system of equations with no solution. We'll end up getting an equation that's just not true. 0 does not equal 1. All right. Here, again, well, this time I'll go ahead and try to get the y's to cancel out. So to get negative 8y and positive 4y to cancel, I need the positive 4 to become 8. And so I'm going to take the entire second equation and I'm going to multiply it by 2. So I'm dropping down my first equation. And then for the second equation, I get 6x, positive 8y, positive 14. And I'll go ahead and I'll add those straight down. So that cancels out, that cancels out, and that cancels out. So it's a similar situation to what happened in the previous example, only this time we get something that's true. 0 really does equal 0. That's true. So what we say here is infinitely many solutions. Infinitely many solutions. I'm going to show you what that looks like. So here is the picture of that. We've got our equations, I graphed them. And you can see that of my two equations, I had one that was blue and one that was black. And all we can see is that blue line. The black line looks like it's gone because it looks like I graphed the black one first. When I graphed the blue one, it went right on top. So every single point is an intersection because they're the exact same line. That means that every single point on the line is a solution. And there are tons of points on the line. There's one right here, 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 one right there, one right there. And so that's why we say infinitely many, because there's no limit to how many answers you could get for that system. All right, one more in this elimination section. So here, the y's are going to be harder to get rid of because 2 would have to multiply by a decimal to become negative 7, and I probably don't want to do that. So what I'm going to do is I've got 2x up here. I want to have a negative 2x on the bottom so it will cancel out. So I'm going to multiply the second equation by negative 2. And I know on all these examples that we always multiplied the second equation, but you can always multiply the first equation. It doesn't make a difference there. You just do whatever's easiest. All right, so the bottom I'm multiplying by negative 2. And I get negative 2x, negative 4y, and positive 6. And then I'm going to go ahead and draw my line and add straight down. So I get 0, negative 11y, and 0. And then to solve by y. Now notice this is different than this was up here. 0 equals 1, that's not true. But if I look here, it's okay for me to have a 0 because I still have a variable in the problem. Negative 11y equals 0. So I'm going to go ahead and finish it. I'm going to divide by negative 11. And 0 divided by any number is just 0. So that means my y coordinate is 0 for the point. And now I can go ahead and go back and plug that y coordinate in. So I'm going to take this equation right here because it looks the easiest to plug it into. I've got x plus 2 times my y coordinate equals negative 3. And so that zeroes out and just get x equals negative 3. So when I write the point where the two lines cross, it would be negative 3 for x and 0 for y. So there's my solution. All right. Next, we're going to solve using substitution. So with substitution, it means that at least one of your variables is isolated. Here you can see that the y value is isolated in both equations. And if it's not isolated, then it should be easy to isolate. So If you see that a y is by itself, you can just plug it in for the y in the other equation. Now this one is kind of interesting because they are both alone, both of those y's are, and since they're the same letter, they have to represent the same missing number. So if these two y's are the same, then this entire part right here should also be the same, the top and the bottom. So what I'm going to do is I'm going to say if these are the same, those are the same, and I'm going to set them equal to each other. All right, so now I'm just solving an equation for x. I don't have anything to distribute. I don't have any like terms to combine. So I'm going to get all my variables to one side. I'm going to go ahead and pick on the little guy. Negative 4x is smaller than negative 3x because it's more negative. So I'm going to go ahead and move that one over. Negative 3 plus 4 is 1, so just 1x. And then to get the x alone, I'll go ahead and add the 9 to the other side. So the x-coordinate of our point is negative 4. Now, just like the previous examples, we have two different places where we can plug in that x value, and it doesn't matter which one we use. So I've got a 4 and a 13, a 3 and a 9. The bottom numbers are smaller, so I'm going to go ahead and go with that one because it seems a little bit easier to me. So negative 3 times the x value that I got, and then subtract 9. That's positive 12 minus 9. And so the y-coordinate is 3. So my final answer where these two lines cross is at the point negative 4, positive 3. All right, for the next equation, we have one equation that's being solved that's already been solved for y, where it's alone. But in the other one, it's not. So what I'm going to do is I'm going to circle this y right here. And I know what this y equals. It equals all this stuff. So what I'm going to do is I'm going to take that stuff and plug it in for that y right there. So I've got negative x minus y equals negative 4. So first thing, I just rewrote the equation and I left a space for y. Now I know what y equals. It equals 5x minus 20. So I'm just going to go ahead and plug that in. All right, so now I've got an equation to solve. It does have parentheses, which means I need to distribute. I left a huge space there, but the negative is the thing that's right next to the parentheses. So I'm going to drop down that negative x, and then I've got minus 5x plus 20 equals negative 4. Next, I'm going to combine like terms. So I've got negative x and negative 5x makes negative 6x. I'm going to get the variable alone on that side by subtracting the 20 over. And then I'm going to get x completely by itself by dividing the negative 6 over. All right, so I know that x equals 4. I want to find the y value, so I can plug this into the top equation. I can plug it into the bottom equation. It doesn't matter which one I use. I'm going to go ahead and use the bottom one because the y is alone already, and that seems nice. It'll be easy to plug in. So I'm going to say y equals 5 times the x value that I found minus 20. 5 times 4 is 20, so that's y equals 20 minus 20. That means that my y-coordinate is actually 0. Right, so that point is 4, 0. There's my solution to the system of equations. All right, here, this one is a little bit tricky because there is not a y that's all by itself, and there's not an x that's all by itself. So if I look at these equations, I can see at least that this y right here doesn't have a number in front of it, so I'm going to focus on this equation for a second. Just going to cover that one up. To get the y alone, I'm going to go ahead and subtract the 6x from each side. So I've got y equals negative 6x. So even though I wasn't given an equation that had the y alone to begin with, I do have that now. So that's what I'm going to go ahead and work with. And I'm going to take what y equals and I'm going to plug it in for this other equation right here. So I know y equals negative 6x. I'm going to plug it in right there. So 2x plus 2 times what y is equals 10. And then I know that negative 6x is what I'm plugging in for y. So I've got 2x, 2 times negative 6x is negative 12x equals 10. When I combine those together, I get negative 10x. And then to get x alone, I can go ahead and divide by negative 10. And x equals negative 1. So to solve for y, I just need to take the x value and plug it back in for x. I can plug it into the first equation. I can plug it into the second equation. It doesn't matter. So I'm going to go ahead and plug it into the second equation. 6 times the value I got for x plus y equals 0. Negative 6 plus y equals 0. And then I'm going to go ahead and add 6 and add 6. Get y equals 6. So my solution is negative 1, 6. All right, one last problem. Here we don't have a variable that's isolated yet, but I do see that the x right here doesn't have a number in front of it, so I'm going to work with that equation. I'm going to go ahead and add 3y and add 3y to get that x by itself. So I have x equals 3y plus 5. So now that I know what x represents, I'm going to go ahead and circle this x right here. This stuff that x equals is going to get plugged in for that x right there. So I've got 6 multiplied by what x represents plus 8y equals 4. And then in for the x, I'm going to plug in 3y plus 5. And now I have the equation to solve, so I want to get rid of those parentheses, and I'm going to do that by distributing the 6. And then I'll just drop down the rest of what I have. Now I have some like terms to combine. I've got 18y and 8y, and that makes 26y. And to get the y by itself, I'm going to go ahead and subtract the 30 over to the other side. And then to get y completely by itself, I'm going to divide by 26. So to figure out what the x value is, I just need to take the y value and plug it into one of the equations. It doesn't matter which one I use. I'm going to use the first one because the numbers are smaller and it seems easier to me. So x minus 3 times the y coordinate I got equals 5. Negative 3 times negative 1 is positive 3. And the x coordinate is 2. So my answer here is the point 2, negative 1. All right, so just to summarize, you need to remember that the solution to a system of equations is a point and should be written in the form x comma y. So always writing your final answer as a point.